In this media, you will learn about force balance transmitters. A self-balancing system balances an adjustable mass against a sensed mass, and when the balance is attained, the adjustable mass becomes an indication of the sensed quantity. This system is truly linear, and this is the reason why these types of balance systems are commonly used for scientific work. The only thing is that the scale pointer needs to precisely sense the equality between known and unknown masses. In pressure instruments, pressure is made to act on the surface area of a sensing element like diaphragm or bellows. By the way, the pressure is simply transformed into force, and this makes a force balance pressure instrument. The force balance pneumatic pressure transmitter balances a sensed differential pressure with respect to an adjustable air pressure, which turns out to be a pneumatic output signal. Differential pressure is detected by using a liquid-filled diaphragm capsule, which transfers force to a force bar. If the position of the force bar is disturbed, an extremely sensitive baffle and nozzle mechanism detects it and makes the pneumatic amplifier to send a variable quantity of air pressure to the bellows sector. The bellows presses against the range bar, which pivots to neutralize the starting motion of the force bar. If the design of this pressure transmitter is slightly modified, we may change it from pneumatic to electronic force balancing. Differential pressure is also detected by using the same type of liquid-filled diaphragm capsule that transfers force to the force bar. If the position of the force bar is disturbed, an extremely sensitive electromagnetic sensor senses it and makes the electronic amplifier send a variable quantity of electric current to the force coil. The force coil presses against the range bar, which hinges to neutralize the starting movement of the force bar. The main benefit of force balance pressure devices is the constraining movement of sensing element. A modern diaphragm-based pressure transmitter depends on the spring nature of the diaphragm, and this nature of the diaphragm converts pressure into force. Then this force is further converted into motion, which in turn is detected and converted into an electronic signal. Balancing with the force of the process fluid pressure is not achieved by using the tensioning nature of the spring element. It is successfully done by using either an adjustable air pressure or an adjustable electric current. Force balance devices have notable demerits also, as they seem to be heavy and convert external vibration into inertial force. Also, the quantity of electrical power required to offer sufficient balancing force is such that it is almost not possible to limit below the level required to safeguard intrinsic safety. Force balance pneumatic transmitters. The process pressure acts downward on the flexible diaphragm present in the force balance transmitter. The resultant force is balanced by the back pressure of nozzle that acts upward on the diaphragm. When the supply pressure is slightly greater than the maximum process pressure to be measured, air passes through the restrictions to the base of the diaphragm and finally comes out through the nozzle. At stable state, the nozzle seat clearance is such that the air flowing in the nozzle and the air flowing through the restrictions to the base of the diaphragm are the same. When the process pressure rises, the diaphragm perplexes off the nozzle, which in turn causes the back pressure to rise till it attains a new stable state. When the process pressure falls, the diaphragm goes away from the nozzle, which in turn causes the back pressure to fall till the stable state is re-established. Since the back pressure of the nozzle is connected straight with the process pressure, the signal can be used slightly for indication, recording, or control. Merits. Such types of transmitters are precise. Demerits. Since all the air needs to pass through the restriction, the speed of response is quite less, mostly if there is abundant volume in the output of the circuit. Any leakage in the output side creates an error or even makes the entire unit defective. In order to overcome the above discussed disadvantages, a refinement is designed by using volume booster and constant differential nozzle circuit. The volume booster has an exhaust diaphragm assembly and has two diaphragms that can move essentially and offer a bleed to atmosphere. A differential spring is present on the base of the diaphragm, which at a stable position applies a force of 3 psi, 0.2 bar, exerting on the diaphragm. As a result, the nozzle back pressure acting overhead the exhaust diaphragm is always technically 3 psi, 0.2 bar, greater than the transmitted pressure. Whenever the process pressure rises, the diaphragm forces the seat to move near the nozzle, hence the back pressure of the nozzle rises. This rise in back pressure forces the exhaust diaphragm to move downward, closing the exhaust port, which in turn forces the pilot valve to move downward, and thus the supply port is opened. A decline in process pressure makes the nozzle back pressure to fall, which forces the exhaust diaphragm to move upward such that the pilot valve closes the supply port and opens the exhaust port. This causes the transmitted pressure to fall till the stable state is reached. The air flowing through the restriction, detection nozzle and out to atmosphere via exhaust diaphragm is continuous at balanced condition. Thus you have learned about force-balanced transmitters.